Hey guys, so my name is Madhav Thaker, and today we're going to have a pretty beginner-friendly walkthrough of what RAGs are and how you build RAGs in LangChain. At the very end, for most of the tail end of the session, we'll actually go through a notebook and I'll show you how you can build your own. And we'll be sharing this notebook with you guys so you can literally start prototyping immediately after this session. So again, what are we going to cover? Just talk about the existing issues with LLMs, how RAGs work, and why they will address those issues. Talk about, like I said, the inner workings of what RAGs are, and then just talk about what LangChain is, and finally take it, combine it all together, and walk through a demo of how you can build your own. Cool. So a little intro. My name is Madhav Thaker. I'm a senior MLE at Shopify. If you don't know Shopify, we're an all-encompassing e-commerce business, and essentially we provide an e-commerce platform that supports millions of businesses. So businesses could be anything like Allbirds or Alo Yoga to a mom and pop that is just starting out and selling their own products. A bit about me. I was born and raised in New Jersey. I currently on the West Coast in Los Angeles. Interest, I love to travel, super outdoorsy. This picture is actually us climbing Mount Whitney. We did that last year. Super fun. Yeah, super fun adventure. But yeah, love rock climbing and definitely love hiking. Cool. So before jumping into RAGs, let's talk about some of the limitations that we see currently with LLMs. One big piece is there's going to be a training data cutoff. The newer LLMs like ChatGPT and even Bard, I think, are pretty good about having more real-time data. But if you are using off-the-shelf open source solutions and LLMs, you're often going to run into this similar prompt or similar result that you get for ChatGPT, where it can only answer up to a certain time point, and then you really don't get anything after that. Another big kind of limitation that we see today are the hallucinations. It'll convincingly tell you an answer, but if you probe or actually question it, it'll actually realize that it's incorrect and can really lead you in the wrong direction. The reason I highlight both of these two things, in my opinion, these are the two, I guess, biggest use cases for when you'd want to use RAGs and when it is most impactful when building your own LLM applications. So what are RAGs? Here's a pretty simple high-level diagram of how a RAG would work. So if we take this prompt, did United win their Champions League match this week? Typically, we query the LLM, and then the LLM will get back to us with some results. That's a typical kind of life cycle of LLM applications. But when you introduce RAGs, you allow this LLM to have access to external data to support what it already knows. Where this is really useful, if you want to incorporate real-time information, which is kind of going to be the example that I'm going to be walking us through during this presentation. But if you want real-time information and have that real-time information accessible to the LLM, that is possible when you're building RAGs. You can create this external data store with real-time news, real-time article that the LLM can then reference when it's going to generate a response. So this is great when it comes to the training data cutoff, but let's talk about the hallucination piece. Again, LLMs hallucinate when it doesn't have a complete grasp of the question and the question that you're asking. And so if you have external data, which could be subject matter information based off what your company is working on, the LLM can then go and reference that information to then support how it goes and generates a response to you. So those are two real big use cases and why having this external data set is really helpful when building out these applications. So again, I told you this session is going to be pretty beginner friendly. So I really want to touch upon just the core concepts of what makes a RAG. First, what are vector databases? So in the same example, we have all of these articles. What we need to do is take these articles, which can be anything from like news articles, can be PubMed, research papers, it could be PDFs, any kind of content and unstructured data that you need stored, can then be encoded using whichever sentence decoder that you want to work with, right? Say we want to use something like BERT or even some of OpenAI's off-the-shelf encoders. What we end up doing is taking this unstructured content and creating this semantic representation or these embeddings and storing it in a database that can easily allow us to reference this data, but in this like semantic fashion, right? So I'll talk a quick example of how that works when it comes to vector search. So you have this in the side here, you have this vector database, right? So you have these encoded representations of all of this content, articles, or whatever you want to store to the right here. Now, if you have this query where you say, did United win their Champions League match this week? That query will get encoded in its own representation. So this is just a dummy embedding, but using the same encoders, this query will get encoded. And then using similarity calculations, we can compare how similar that query is to all of those documents that exist in our vector store. And this is kind of pretty much the fundamental of what vector search is in a very simple way. But this is going to be really important in terms of figuring out what parts of this external data source do we want the LLM to use when it's generating a response. And that's going to be key, right? So I can ask a wide variety of questions, but all of the content in that vector data store isn't always going to be useful for that LLM. So that's where vector search comes into play, because it allows this whole architecture to pick only the most relevant items in the vector data store to use when generating a response. So really quickly, how this will end up working is, so now we'll ping the LLM asking them this question: did United win their Champions League match this week? And then it'll ping the vector data store and figure out which article is actually the most relevant to answer the question that I asked. And in this case, let's just say NBC Sports is the most relevant. So then what will end up actually happening is we'll ask this question, the LLM combined with this article will then generate a response for us. So it's now almost constraining how the LLM generates a response by giving it this additional context that it typically wouldn't have had. And that's a really key piece of kind of how these RAGs work and why they're so powerful. I'll take a stop there for a sec and see if there's any questions. Let's see.
I think with Madhav, we had one question from community on this might be later on, but Jin asked, is there a stronger candidate between search and retrieval RAG and hide? So I think the hide paper, but I hear a lot more people asking like search and retrieval and RAG versus fine tuning and prompt engineering. So I wasn't sure if that was something that you thought of.
So this is the way I've thought about it: is fine tuning, in my experience and what I've seen in the industry, is requires the barrier to entry to build a fine tune embedding. I think is a bit higher than incorporating a RAG system. I think both of them are extremely powerful and relevant tools, but as you'll see in this prototype, making an LLM more competent by having it connected to an external database via RAG is a lot more simpler for a team to implement versus fine-tuning embedding and making sure you're not having any knowledge decay or having it divert too much from its core principles. That is a high risk, and unless you have the aptitude and the team that can kind of peruse or wander into that kind of realm while knowing those risks, RAG is probably the more kind of simple approach, and I guess just as powerful of an approach.
All right, and we do have 3 questions from the Q&A. So if you want to tackle these now, but Michael first asked, what is the best vector database for a simple HR app for cost, accuracy, and performance? I don't know how many of them that you have tried, but based on your experience, yeah, I guess what do you find has been like the best most cost-effective vector database?
We've been having, this is all going to depend on the volume of data, the yeah, the volume of data, how quickly of requirements you need in terms of just performance. But I've been seeing quite a bit of uh, some great use cases using Weaviate. I think we're starting incorporating that quite a bit into some of our use cases. So that's a good one to start. I've honestly seen in production, I've seen teams use Vice or Facebook's index because they just didn't need to build that large of a data store, and they actually were able to come up with something performant just using a Vice data set or database, which is kind of surprising, but it's kind of great how much that works, especially if you can GPU enable it. It's actually quite performant, even something that's like off the shelf like that and pretty cheap too.
Yeah, I think Weaviate, Milvus, and Pinecone are what we're seeing used the most, or like what our customers are looking into. But yeah,
Pinecone's
there's a
nice,
lot
but
of
it is on the
adoption.
pricier side of it's like a great solution, but it's if cost is a big hurdle, then it can
Yeah,
be a deterrent.
yeah, I think Milvus and Weaviate are the best open source options. I know Milvus is open source.
Yeah, definitely.
Awesome. And then the next question from Matthias, let's say I'm embedding all messages from a messaging app. Some messages might be really short and um, lack semantic meaning, I'm guessing, without the larger context they belong to. Would it be smart to embed the element with a summary of the larger context so that it retains that semantic meaning?
Have to read that
Yeah, I
again.
think, would it be smart to embed that element with a summary of the larger text? So sometimes.
Might be really smart. Okay, so we're talking about really smart inputs that don't have any semantic meaning. Um,
Wait, and Matthias, can you actually add a little bit more context to that? Do you mean like they're like one's like really short, so it doesn't have as much meaning? Mm, maybe just a little bit more context there. Okay, Matthias is adding more. AJ asked, Matab, just to be sure, the embeddings of the external info must be computed with the embedding functions used by the underlying LLMs. Is that correct?
that's not the case at all. They can be completely different. And if we go back a couple of slides, give me a sec. So the key piece, so let's go to this one, right? Actually, yeah, this one. The key piece is from from a vector search perspective, all we need that to do is take the query and find the most relevant piece of context in your vector database, and then add that as context in your prompt. And we'll actually look through an exact example of that when we go through the demo. But all we need to make sure is the way the query is encoded matches the way the vectors encoded in the database. If that aligns, then we can accurately pick out context that can be plugged into the prompt when we go to actually query the LLM. So it's actually completely different. And yeah, so like whatever works for like, however your vector database is encoded, or if you have storage constraints and you don't want to use something of size, say like 1028, 1048, or you need something smaller, like maybe E5 embedding, you can do that if you want to, if that becomes a concern for you.
Perfect. There's more to talk, but I'm gonna let you keep going a little bit,
Sounds good.
and then we'll come back.
Sounds good. And how I've been doing this recently, because I'm having a lot of fun just like hacking up random projects and noticing that it's actually not the worst solution if you want to build something in production, but it's kind of a controversial topic. Some people say no, some people say yes. I think you have to see what makes sense for your use case. But the reason I really do like LangChain, it's a completely modular framework. And by modular, you can literally plug and play depending on whichever vector database you want to work with. So if I started building a prototype with Vice because it's quick and I don't want to actually install or create an account with say Weaviate, I can start there. And then when I am ready to maybe move on to something a little more structured and robust, I can easily just plug in classes for that Weaviate vector store without any code changes. So it's really nice to just build, scale, and like adapt to whichever new kind of tools you want to use. What's also great is a big issue in building some of these LLMs from scratch is you want things to be context aware and conversational. That is actually really difficult to build from scratch. But what's nice about LangChain is you have a lot of conversational agents that you can build and also slightly adapt to whatever your use case is. And that is kind of just built off the shelf and quite powerful as well. So it's kind of a nice tool to um, give you this like tool set to give you almost like a pretty intuitive app that you want to build without actually needing to create all the code from scratch. And I'll share this as a PDF, so all of these links and docs will be available to you guys after. Cool. So let's jump into the prototype, the actual fun part of all this.
And Sarah shared the notebook, so everyone has the ability to go through it.
Great, thanks. So this notebook, we have all the imports. So if you want to run this, you should be able to run this end to end. Feel free to ping me if anything isn't working. One thing to note about the environment I'm in, so I'm working in a Vertex notebook, and I'm only using an L4 GPU, a single L4 GPU. Again, I think that's the beauty of this is you're going to be able to build something quite powerful and quite coherent without actually needing some large compute, which is a big bottleneck or a big obstacle for I feel like any practitioner who's trying to get started. So let's kind of jump through this a bit. First, so what I'm using here is the Mistral 7B. I know Mistral did release a bunch of kind of cutting edge mixture of experts. This is the slightly older version of that. I'll probably update this with that model once I get some time, but this is the Mistral 7B model that was created a few months ago. And in particular, this is the instruct, which is fine tune on the instruct dataset. All of this code, I'm not going to go into this because this is just more of loading the model. But what we do have here is us loading a quantized version of this. So when we actually take a look at the number of, or the percent of parameters that we're actually interacting with or able to train, it's only 7% of parameters that we're actually loading and kind of working with in this notebook. So yeah, feel free to take this. This is just how we can load the Mistral model and get it ready to use. So the first piece to make this usable in LangChain, we have to first build a pipeline for our Mistral model. And the beauty of Hugging Face, it's a pretty simple, pretty simple code here to kind of basically create a text generation pipeline using off-the-shelf tools. Cool. And now at this point, we have a Hugging Face pipeline. And so this is getting into LangChain's documentation and LangChain's API. So this Hugging Face pipeline, we can then allow the LangChain tool to interact with whatever we build in whatever we built using the Hugging Face tools. Now, loading the data. So this is the beauty of how simple it is to start prototyping with LangChain and prototyping what your potential RAG could look like. So in my case, I was building a fantasy football tool that will have access to recent information. All we need to do is pass in these articles as you see here. And this is static, but if you want to build your own application, it's actually not that difficult to create this via some API to consistently load more and more articles as you stream data in. But for this exercise, we're just loading in 5 articles. This is all, again, using LangChain's tools. We have this async Chromium loader, which will load these articles. Then we have this, I guess it's a chunker, I'll call it, but it's essentially what it splits the data that you're loading into certain chunks. And this could be useful for really large corpus, or it just depends on your use case. But yeah, it just depends on like how much context will each chunk have, right? And I think you should look from case by case basis. But using this cell here, we will chunk all of the data and then load it into the FICE database. And like I said, just like that, we're able to kind of set up our index and get that ready to be used in our chain. One thing to note here, so Hugging Face has a wide variety of embeddings, so you can play with whichever embeddings you want to. So if you go to the Sentence Transformers website, there's a wide variety. It doesn't matter whichever one you want to use, and I think this kind of ties into one of the questions before. This can be any set of embeddings that you'd like, and it could be something that you've built as well. If you have something domain specific, like say medical, you want to build a medical RAG, right? So you can use one of the like PubMed-based fine-tuned embeddings here, just so that when you are trying to retrieve documents, you are able to encode in the correct space. Moving along, so you start to see all this does is it chunks all the data and then loads it into the FICE index. We set it up as a retriever. This is essentially kind of the function that allows our chain to communicate with the FICE index. Now jumping into kind of building the prompts and kind of building the LLM chains. So here's a really simple prompt template we can use, and these can get more and more elaborate. But what you'll notice here is in our prompt, we have the question, right? So whatever I'm prompting will get inputted into this piece. But then we also have this section for context. And that's kind of how we let the RAG vector data or vector search interact with the LLM chains. So as you'll see in a sec, what we eventually want this pipeline to do is take the query, find any relevant context, include that context into this prompt, and then allow the LLM to go and respond to whatever your query is. So if we take this one example, and if we have time, we actually play with other news sources after, but take this simple example about fantasy football, right? And we ask this question, like, should I start this player this week? And if you look at this response, it's pretty vague, right? It's based on my general knowledge of this, this could be decent, but you should really consider all of the other options and consider whether you have a solid lineup. This is like very generic, and you've probably seen this, very generic response from an LLM when it doesn't quite have the knowledge it needs to respond to your question. And now let's actually connect the retriever and see what happens there. So here we have this context, right? So this is I'll call the RAG chain. This is like the slightly elaborate version of the LLM chain we were playing with here. What we do is we set up the two inputs that are going to go into the LLM chain. Instead of having a blank string for context here, we'll actually place the retriever. And so this little piece here, is actually performing that task of having LangChain go and communicate to the vector database, retrieve responses, and then incorporate that into the prompt, which I think it's the beauty of LangChain, right? It's like such a simplistic implementation to give you a pretty powerful tool. And then the question, this is a tool that, or just a utility to make sure whatever you invoke, so whatever text you pass gets passed through and will go into the LLM chain. So this is just kind of what's called LangChain syntax. So then let me try to ask that same question. So I'm going to invoke the same question. Should I start Gibbs next week for fantasy? And let's see what's actually happening. So in this results, we actually see that we retrieve all of this context that could potentially be used for the LLM to respond. And so you see, let's see, we could look at some of these. Oh, sorry about that. Let's just check and see if this is recent. Let's give that a sec. I guess while I'm pulling this up, I'm not sure how much of you guys have played with Mistral, but it's just worth noting how coherent just a very simple, lightweight 7B model can be. I know they've gotten even better the past week with their mixture of experts paper, but yeah, I think it's kind of, I know as I've been exploring this and like playing with these new models, it's kind of nice to see how you don't need a 70 billion parameter model to really get good results. Cool. So now if we look at this, so now if we look at this result, if we compare it to what we have here, so this was a pretty generic response and didn't really have much knowledge. And now using all of this context, it's starting to give me really specific information about what is happening over the past few days, right? And so now with just a kind of handful number of lines of code, we're getting really specific information about the question that I asked, which I think would end up making this a pretty useful tool if someone wanted to use on a week-to-week basis. And this is a hard-coded example, but let's think about how this would be used in practice, right? If we think about maybe productionalizing something like this, FICE in some cases could work, but maybe we move to Weave8 because it's more stable and it's easier to manage. If we had a pipeline that is, say, scraping this website consistently day after day and chunking and loading the Weave8 index with whatever we input, just something as simple as that, right? That's pretty low engineering lift. Just something as simple as that can then give us real-time information using the rest of this code as it is. The rest of this code would not need to change at all. All we need to do is create a relatively simple pipeline to scrape and load data on a day-to-day basis, right? And this kind of, I hope, illustrates why I consider RAG to be the much lower barrier to entry for incorporating relevant information for your use case. If we think about the alternative example of maybe fine-tuning an LLM regularly so it has this context, that ends up becoming a much more burdensome process to train it frequently enough to give it this content, but also manage that training process, manage those costs. That ends up just becoming much more overhead versus building something like this. I will say fine-tuning I've seen is a great use case if you do have a more domain-specific vernacular. If you are trying to build your own index that is really specific to your domain, then RAGs will fall short because you're using a lot of off-the-shelf embeddings. You're using off-the-shelf LLMs, which may not pick up on a lot of the terminology that you use. But for us, because e-commerce is pretty general in the verbiage, right? It's a typical LLM can probably load and work with a lot of e-commerce data. In our case, RAGs are quite powerful because the vernacular is similar. It's more of just giving the LLM the most up-to-date information. But I'll stop there. I feel like that's essentially most of the prototype, and I hope that kind of illustrates how concise and simple RAGs can be to build when using LangChain.